Were meteorites a crucial factor in the development of life on Earth? By Emily Wood, Ronnie Z, Angie Baker, Chloe Oldfield, Lucy Worthington, and Lana Dorr.
In order for there to be life on Earth, we need four main components: a source of energy, water, carbon, and other CHNOPS or CHNOPS elements, which are an acronym for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, and finally an atmosphere. Energy is vital in order for all life processes to be carried out, an example of which is the sun and photosynthesis. Water, with the property of dissolving many different materials, is nicknamed the universal solvent. As a part of the metabolic reactions that power life, it's also a key component to life on Earth. Carbon is also key in life's biology. This is because all life on Earth is carbon-based, whilst other elements help form biomolecules, from which organisms develop. This makes carbon a fundamental building block for life on Earth. And finally, our atmosphere protects life on Earth from solar and cosmic radiation. But more than that, it also prevents heat and oxygen from escaping into space, allowing important life processes to take place. We will be discussing to what extent meteorites on Earth contributed to these fundamental aspects of life. The origin of organic materials found on Earth is a highly contested subject that is still debated even today. There's evidence for two main origins, on Earth and in space. However, many believe that they both had a large impact. The evidence for an Earth origin comes from the Miller-Urey experiment, which simulated Earth's nascent atmospheric conditions. Using electricity to mimic lightning, which would be an energy source, it proved that complex molecules and amino acids could have originated on Earth. However, there's also evidence for the origin of organic molecules being in space. The Murchison meteorite is an example of a meteorite that was discovered on Earth, containing over 70 amino acids. These meteorites show that it's possible for complex organic compounds to exist in our solar system, and that they can be delivered to Earth. Since both origin theories have sufficient evidence to support them, many scientists believe that both played a significant role, and that neither was a sole source of organic material on Earth.
Did meteorites bring water to Earth? Deuterium is an isotope of hydrogen, and the relative amount of hydrogen compared to the deuterium is called the DH ratio. This is useful in identifying where water came from, as different origins have different ratios. The DH ratio has, however, contributed to the rejection of the comet theory. This is because the ratio found in comets is around twice that of some of Earth's water, meaning it could not be the only source. The ratio in meteorites is much more similar to Earth's water, suggesting that they are more likely to be the source.
Although meteorites are a strong contender for the delivery of water, there are other strongly theorised concepts. One of these being ancient volcanoes that expressed hydrogen and oxygen as water vapour, which once temperatures had cooled and the atmosphere was created, it condensed into liquid water on the surface.
Theia is a theorised protoplanet that collided with an early Earth. It possibly delivered water and the impact remnants that created the moon. This concept is known as a giant impact theory or hypothesis. The theories also overlap, with most scientists agreeing that Earth's water did not come from a single source, but from an amalgamation of some of these theories.
The location of the origin of life is another debated unknown, but there are several candidates proposed by scientists that you can see on screen: meteorite craters, hydrothermal vents, and hot springs. There is also the overlap between craters and hydrothermal vents, with some scientists proposing a combination of the two. They all contain an energy source, access to water, as well as access to minerals. Our conclusion. Although the specifics are debated, evidence suggests meteorites significantly influenced the origin of life on Earth. They most likely contributed organic materials, water within the rocks, and energy from their impacts. Of our 4 initial points, water, an energy source, the CHNOPS elements, and an atmosphere, this clearly indicates they impacted water and energy, but not directly the atmosphere. The CHNOPS elements are more complicated, as they are abundant on both Earth and meteorites. Therefore, the debate focuses more on if organic compounds formed from these elements were transferred by the meteorites or not. Overall, we think it's safe to say that meteorites had a crucial role in the formation of life on Earth.